In lesson 26, we are factoring trinomials and we're looking at overlapping right triangles. So in example 1, we're going to factor x squared plus 6 minus 5x. The first thing we need to do is put this in descending order of the exponents of the x. So I need my biggest to smallest. So I'm going to have x squared minus 5x plus 6. And this is going to factor into two binomials. To get x squared, we would have x times an x. Then we need to think of numbers that would multiply to give me 6, but add up to give me a negative 5. Now, since this is a positive 6, we know the numbers are going to have the same sign. Since this is negative, that means both of their signs are going to be negative. And then the factors of 6, there's 1 and 6 and 2 and 3. And we're going to use the 2 and 3 because they add up to give us 5. Then we can check ourselves by multiplying out the middle, that's a negative 2x. And then the outside, it's a negative 3x. And adding those together, which is a negative 5x. So we have factored this correctly. Okay, we're going to do the same thing on our next example. But because we have this negative in front of our x squared, it's already in order, but that negative would make it much harder to factor. So what we're going to do is factor out a negative 1 first, and that'll just change all their signs. So I'll have a positive x squared minus 5x minus 14. Then I'm going to factor this x squared minus 5x minus 14, which will be much easier than having a negative x squared. Okay, we know that to get x squared, we're going to have an x times an x, so those are going to be in the front. Then this time we have a negative 14, so the negative means that the numbers that multiply together are going to have opposite signs. We're going to have a positive and a negative. Now I need to think of factors of 14 that would have a difference of 5. So if I list out my factors of 14, 1 times 14, 2 times 7, we've already got the factors that would multiply or add up. They would multiply to 14 and then have a difference of 5. And because the 5 is negative, that means my bigger number needs to be negative. So the 7 is going to be negative and the 2 is going to be positive. Now, to check ourselves, again, we can multiply the middle and then multiply the outside, then add them together, and they do give us the correct middle term. So we factored this correctly. We could leave our answer just like this, but it's more standard to have that negative x put back in. So we can have a negative x minus 2 times x minus 7, or we could keep the x plus 2 positive and have a negative x plus 7. So both of these answers are correct. You just need to decide how you want to write that in the end. Okay, our next example, we need to put these terms in order. We would have a negative 3x squared plus 6x plus 24. And then here we have a common factor and we have a negative x squared. So we need to factor out a negative 3. So I'm going to put negative 3 on the outside. And then I'll have an x squared minus 2x minus 8. Then I'm going to factor that trinomial into two binomials. We know that we're going to have an x times an x to get x squared. Then we need to think of what are the factors of 8 that would combine or have a difference of negative 2. So 8 and 2 and 4 would fit that. So I'm going to use a 2 and a 4, and because this is negative, they're going to be different signs, and that's why we're looking for a difference of 2. And because that 2 is negative, I need to make my bigger number negative, so I'm going to have a negative 4 and a positive 2. And I'll check my middle terms by multiplying the inside and the outside. I'll add them together, and that does give me a negative 2x. So we're just going to leave this as it is because we had to factor out a negative 3, not just a negative 1. So I would just leave our answer like it is. Alright, the next example is another one of factoring a trinomial, and we're going to need to factor out a common factor first. Now I'm going to arrange this in the correct order. I'm going to have negative 2x to the 4th plus 12x cubed plus 32x squared. And I see that I can factor out an x squared from each of my terms. And I can also factor out a negative 2. So that will make my first term positive, which is much easier to factor. So I'm going to have an x squared minus 6x minus 16. Okay, now this is just going to keep dropping down when we factor. You don't want to forget that since we factored it out. So I'm going to have an x times an x to get x squared, and then I have 16 that my numbers will multiply to, and it's negative, so they're going to have opposite signs. I'm going to have a negative and a positive. So I'm looking at factors of 16 that have a difference of 6 since it was negative. So I think of 2 and 8, and if you don't think about that right off the bat, just list out the factors so you can find out which one it is, which pair it is. Since my 6 is negative, I need to make the bigger number negative, so I'm going to have a negative 8 and a positive 2. And then again, we can check ourselves, multiply the inside together, so that's a negative 8x, and the outside together, which is a positive 2x, add them together, and that's my negative 6x, which is correct. So we just need to leave this just like it is because we factored it correctly. Alright, our last example, example 5, says to find A, B, and C. So what we need to do, or what we could do to make it a little bit easier, is to write this as two separate triangles, the small triangle. Here I have a 6, a 4, and then A. And then for the larger triangle, I have 6 plus 4 on bottom. So that's going to give me 10. I just added those two together to get that total length. And then I have a C and an A plus B. So first I need to find A by using the Pythagorean theorem. So I have A squared plus B squared equals C squared, so that is A squared in this case. And the 6 and 4 I knew were the A and B from the Pythagorean theorem. A squared plus B squared equals C squared. because they are the legs of the right triangle. So I'll have 36 plus 16 equals a squared. Then I'll add those two together. So I'll have 52 equals a squared, and I'll just take the square root of both sides. So that'll cancel out the square, and that'll be 2 square roots of 13 equals a. Alright, and then we need to find out what c is. So I can say c over 4 equals 10 over 6, which we've been setting up these ratios and proportions for a while now. So this isn't very new. And we've used the Pythagorean theorem before also. So c equals 40 over 6, that's going to simplify. C equals, if we just divide by 2, 3, and 20, so 20 over 3. So now that we have a and c, and we need to find out what b is, I can fill in that 2 square roots of 13 for the a here. And I can make a ratio. And I can use either 6 and 10 or my 20 over 3 and 4, which I'll use the 6 and 10. I just think it's easier, so 10 over 6. So I'll multiply both sides by 2 square roots of 13. So these will cancel. So I'll have 2 square roots of 13 plus b equals 20 square roots of 13 over 6. And I can simplify that. That would be a 3, and that would be a 10. And then I can just subtract the 2 square roots of 13. So b equals, see, it's 10 thirds square root of 13 minus 2 square roots of 13. So I would change these to have a common denominator of 3. That's going to be a 6. So I'm going to have 4 over 3, and that's the square root of 13. And that's what b equals. So it's a little bit longer than it was before we had to use the Pythagorean theorem, but it's still not too bad. You guys can do it.